Dear students, in this video we are going to discuss about binary search. So binary search requires a sorted list. That means we should give sorted list as an input to the binary search technique. What is sorted list? The elements are arranged in either in ascending order or descending order. That we call it as sorting. So binary search algorithm or binary search technique requires the sorted list. So it means the element should be in either in ascending order or descending order. So that is the important feature of binary search technique. It expects the sorted list as an input. So this is the algorithm. In this algorithm, the key component is finding the mid position. So how to find the mid position? Low plus high, low index plus high index divided by 2. It gives you the mid position. So this is the important portion of this algorithm, finding the mid position. Binary search. So our key element is in this example, the key element is 33, and here we have a, as I told earlier, here we have a sorted list. So in this example, the elements are arranged in ascending order. So already elements are sorted. So we have a sorted list and the key element is 33. So we have to find whether that key element 33 is present in the list or not. First, let us start with the start index, that is CO. Call it as a low and take the last index, that is high. So low plus high divided by 2. 0 plus 14. 0 is the low index, 14 is the high index. In this example, 0 plus 14, low plus high divided by 2. So 0 plus 14 divided by 2 is 7. 7 is the mid position. So 7 is the mid position. So now the mid position is clearly dividing the list into two lists. One is, and in this example, now the mid element is 53. So now the mid position is clearly, mid is clearly dividing the list into two sublists. One is right part of the 53 and left part of the 53. So we can call it as left list and right list. So now we have to compare key element with mid element. So now the mid element is 53, 53 and 33. We have to do the comparison between 33 and 53. 33 is lesser than 53. So what we can guess, the key element is present in the left part of the array, not in the right part of the array, because the key element is lesser than 53. So 33 is lesser than mid element, so that we can guess that. So 33 is present in the left part of the array, not in the right part of the array. So in the next iteration, what we have to do, so 33 is not present in the right part of the 53. It is present in the left part of the 53. So that we have to consider only the left portion of 53. So that means what? Left list of 53. So the left list containing 6, 13, 14, 25, 33, 43, 51. So we have to consider only these elements for the next step. So here, ignore the right list, consider only the left list. So now again we have to compute the mid position. So now the low index is 0 and high index is 6, because here we have considered left list of 53. So in the left list containing 6, 13, 14, 25, 33, 43, 51. So now the low index is 0 and high index is 6. So again we have to compute the mid position. Low plus I divided by 2. 0 plus 6 divided by 2. It is 3. So 3 is the mid position. So now again mid is dividing the list into two lists. One is left list of 25 and the right list of 25. 25 is the mid element. So again we have to compare 33 and 25. So we have to compare key element with the mid element. So 33 is greater than 25. 33 is greater than 25, so that what we can conclude, the key element is present in the right part of the 25. It is not present in the left part of the 25. So that in the next iteration we ignore the left portion of 25. So we give focus only on right part of the 25. So right part includes three elements: 33, 43, 51. So in the next iteration we have only three elements: 33, 43, 51. So again we have to compute the mid. So here the low is 4, high index is 6. So low plus high divided by 2, it gives you the mid position. 6 plus 4, it's 10, divided by 2, it's a 5. So now the mid element is 43 and the mid position is 5. So now again the mid is clearly dividing the list into two lists. One is left list and the right list. The left list containing 33 and the right list containing 51. So again we have to compare our key element with the mid element. Key element is 33 and mid element is 43. So key element has to be compared with mid element. So now 33 is lesser than 43. It means that 33 is present in the left portion of 43. Obviously it is not present in the right portion of 43. So when it is not present in the right portion of 43, so that we ignore the right portion, we consider only the left portion. So that is 33. So left portion containing only one element, so that at last we we have only one element, that is 33. So here low and high are the same because both are representing the same. Here the low is also 4 and high is also 4 because there is only one element. So 4 plus 4 divided by 2, 8 divided by 2, that is 4. So mid position is 33. So now mid is also the same element. So now the key element has to be compared with mid element. So 33 and 33, see both are same. So now our key element is also 33 and mid element is also 33, so that search is successful. So that so we should display the message at the hand, search is successful. Element 33 is present in the list. So this is the binary search algorithm. Like this, the binary search algorithm works. It's a very simple searching technique and it is efficient than linear search. In a binary search, the major mm, logic is the prominent logic is we have to take the two index low and high and we have to divide it. We have to add low index and high index and we have to divide it by 2 and it gives you the mid position. The mid position clearly divides the list into two lists. One is left list and right list. Then we have to compare the key element with the mid element. If it is lesser, it means that element is present in the left list. Suppose if the key element is greater than mid element, it means that key element is present in the right list, not in the left list. So Based on the comparison, we can consider either left list or right list. So this is the binary search algorithm, and it requires the sorted list as an input and efficient than linear search. This is the algorithm, and in each time the mid element has to be compared with key element. When key element is matched with the mid element, so then display the message element is found. Thank you.